Okay, dear students, for independent events, we would be considering an example over here. We have to calculate the probability of getting at least 1/6 when throwing three different dices. So its solution may be expressed as we know that the sum of the probabilities must be 1. So the probability of no 6 on any dice plus probability at least of 1/6. The sum must be equal to 1. Or if you subtract one term from the other, we can also write it like this: probability of 1 minus probability of no 6, that is equal to probability of at least 1/6 in the form of equation number 1. Likewise, probability of 1 minus probability of at least no 6 is equal to probability of no 6. So probability of no 6 is equal to P1 into P2 into P3. We can write the three probabilities in the form of products. There is no 6 on the dice 1, there is no 6 on the dice 2, there is no 6 on the dice 3. So that is equal to means there are other 5 numbers out of 6. So 5 over 6 into 5 over 6 into 5 over 6, we get the product equal to 125 divided by 216. It means probability of no 6 is equal to 125 divided by 16. If we insert this value in the above equation, we get probability of at least 1 6, that is equal to 1 minus 125 divided by 216, that is written over here. So if we solve this term, we get 91 divided by 216, that the answer is in the fraction 0.42, or in the form of percentage you can express it as 42%. Now we come to the next topic, that is counting the number of events. The process may be performed if we have the idea of the arrangements and the permutations. These are two different functions. We'll discuss both of these one by one. And the combination of events. We start our discussion by initially talking about the arrangements. Arrangements, you can say the number of ways of arranging n dissimilar objects in one line. It may be specified by n factorial, that is written over here. Let we have 10 dissimilar sticks of chalks, then 10 factorial is equal to 10 into 9 into 8 up till 1. At start we have 10 choices, after placing one we have 9 choices, after placing the second we have the 8 choices, and so on. In this way, after placing one chalk stick, the number of choices decrease by 1. Suppose we have 3 dissimilar objects A, B and C. Then the number of arrangements, possible arrangements, that is equal to 3 factorial. 3 factorial is equal to 3 into 2 into 1, that is equal to 6. So all possible arrangements may be written like this: ABC, BAC, CAB. Those are written over here. Likewise ACB, BCA, CBA. Those are written over here. These are the only 6 arrangements, possible arrangements, and no other arrangements for these 3 dissimilar objects is possible. Likewise, for n dissimilar objects, the number of ways of the arrangements, that is equal to n factorial. Now if we have 3 objects but 2 of them are similar, for example A and B, then all the possible arrangements are AAB, ABA, BAA, and no other arrangement is possible. So number of arrangements, that is written like this: 3 factorial divided by the factorial of the similar objects, 2 factorial also divided by factorial of the remaining objects, 1 factorial. So the answer is written like this: 3 factorial divided by 2 factorial divided by 1 factorial. For example, if we have one kind of objects, those are specified by P, second kind of objects represented by Q, third kind of objects represented by R, and so on. So number of ways of arrangements may be written like this: n factorial divided by first kind, second kind, third kind factorial. So this will give us the number of arrangements for the given case.